Welcome, and I will be discussing network published shared variables in this video. So they are a bit different from the single process shared variables. So here I have a project which includes my computer and a real-time module. So in this case I am using Compactrio target. So I actually don't have a Compactrio attached to my computer, but you can just in case you want, you can just go to projects, right click, and targets and devices, and if you don't have anything connected, set it to new targets and devices or device, and then you can choose whatever target device you want to choose from here, so that once the Compactrio is connected or any other module is connected, it can be configured with this thing. So I have these network published shared variables in this video, and these are the two programs which I want to in which I want to share the variables. So this is my host PC and this one is my real-time module. And before I start, I'll just go to this and show you how to set shared variables. You can go to new and variables. So the network published share variables are used when I want to communicate between my PC and a real-time module which is connected to my PC. It could be any module, it could be a Compactrio, MyRio, or any other type of module you have. And here you can set the options. We have a couple of options here. Single process variables are used when we are communicating within the same program or different VIs, but a network published is used to communicate over the Ethernet network, and the internal implementation of this is considerably more complex. It also allows real-time FIFO, and if I enable this option, I can set real-time FIFO, which could be single element, multi-element, and use network buffer configuration. Okay, so real-time FIFOs are basically a first in, first out provision which is provided in shared variables, and each reader of the network published shared variable gets its own real-time FIFO in both the single element and multi-element real-time FIFOs. So the variable which goes in first is read first. So it maintains a basic FIFO system, which is very commonly used in other systems as well. So we can also use network buffering options. So if I go here, I can use buffering options. So which allows you to specify the size of the buffer in the units of the data type. With buffering, you can account for temporary fluctuations between read-write rates. So if the readers can occasionally read slower than the writers, and this buffering allows the reader to get all the information so that they don't miss out on any information. If we use both network and real-time FIFOs, then multiple writers and readers will be allowed, so that they do not block each other from writing or reading. So if we use only network buffering, then there are separate buffers maintained for the readers. But in addition, if we use real-time FIFOs also, then we have separate buffers for the writers as well as the readers. So these are the options we have over here, and I've already chosen the options and kept it ready, so I'll not be doing that. Here I have set the variables which are shared wave signal, and then I have a stop which is a boolean shared variable. Then I have this shared number of iterations, and then shared signals. I'll show you this in this program. And if I go to the block diagram, you can see that I have these shared variables over here. So shared variables, what it does is it actually writes the information. So it is taking the input from here and it writes to the network shared variable. So if I go to here access mode, I have chosen this write option from here. So it is writing the information, and this is also writing the information, and this is the third one which is writing the information. So now what happens is if I change my signal in this program real-time module, this is my real-time module, it will automatically get reflected on my PC. So this is the PC, and this is the stop. Stop is actually not writing the information, it is reading the information. So if it is connected towards the left, it is writing the information, and if it is connected towards this right, then it is reading the information. It is reading the information from this PC. So this PC is just writing the stop information, and rest all of the information, whether it is graph, whether it is this signal, or it is the iteration counter number, it is reading from here, which is a network published share variables. And you see this sign, this little sign, if you can see this little sign, red sign in this block, this means that I have chosen the real-time FIFO option. But right now I won't be able to run the program and show you, because I have no real-time module connected to my system. But this program should run, and it will run if connected to a real-time module. So this way you can share the information between your host PC and your real-time module using the network publish share variables option in LabVIEW. Thank you.